Python ingestion and query.py. So it has generated all 13 chunks here. Let me maximize this console. Then I will ask a question here about the leaves, how many leaves I have. So you can see here it has generated the answer. As my question is very generic about the leaves, it has generated me answer which includes all the types of leaves and how many leaves I have. Hello everyone, welcome to We Can Automate. In the previous session we have learned how to store the embeddings in the vector database. If you have not watched the previous sessions, link is given in the description, you can go and watch it. In this session we are going to learn about retrieval phase, that is nothing but building a chatbot and getting the answers from the Ollama in a smart way. So let's start with that. In the entire session we will be learning these topics, that is top K search, what is top K search, and how retrieval phase works in the RAG, and we are going to write a code to convert the query to embedding vectors. Then we are going to build a chatbot and we are going to write a code for that. So first thing is, what is top K? Top K is a number of most relevant chunks or documents retrieved from the vector database and sent to the LLM as a context. Assume that you are sending query here as a user. That query will be converted into embeddings, that is nothing but the vectors. That all the vectors will be sent to a database, and from that database where it will have the huge document and all the collections and all the chunks and all the vectors which we have stored for the entire document, from that entire document it will pick up the top 3 matching results, and that top 3 matching results is nothing but the top K. That K is nothing but the number which you are configuring here. That is configurable. If you have a less number of document, or if the document is very small, you can give the less number here. If you have a huge document, then you can provide the K as a larger value. And once you get the top 3 results, you will send that top 3 results to LLM to find an answer. How these top 3 results will look like is, top 3 results will have some ranking. So each ranking will have some value. So for example, this is the rank 1 and it will have this particular chunk and the score. So what is the matching score for this entire chunk, that will be given here, and all these ranking will be displayed and it will be sent to LLM. So why this top K matters is, if the number is very small, it will do a retrieval in a faster way and less token, because if you are sending only the one chunk, or if you are sending only the top 1 result, then the token usage will be less for the LLM, and if you are sending less rankings, then you might miss the other information or the other important information from the document. If you are configuring the higher value, then you will be sending more context to LLM. If you are sending more context, then you will be consuming more tokens. That is again the cost, and it will take time to retrieve the documents and it will take time to answer. There is a latency involved and can introduce irrelevant information. If you are sending too much information to LLM, then it might hallucinate and give you a wrong answer also. So if you have a small document, keep number as 3 to 5. If you have a bigger document, then keep the number 5 to 10 and so on. So how do you configure this top K while querying the database is, you'll be using client, and this is a method query points to search into the vector database, and here you are sending a collection name, and then whatever the embeddings which you have generated for the query, that you will be sending, and on top of that you will be sending limit. This is nothing but the top K. That means that retrieve the top 5 most similar chunk from the entire database for the given question. Then how we are going to use this top K concept in the RAG is, when you are sending a query and it generates into embedding for a given query, then it will go and search in the vector database by using a cosine similarity. This is the concept which will be used in the vector database to find the most relevant answers from the entire document for the given question. Then it will give me a top K retrieval, that is nothing but the top 3 results here, and once you get the top 3 results, you will build a prompt. That prompt will include some system instruction, that how this LLM should behave. You will be providing some instructions to the LLM, then you will be adding the question, what is the actual question which you are sending here, then you will send the top 3 results which you have got from this phase. That the entire thing will be going as a prompt to LLM. LLM could be anything, it could be of any LLM. Here we are using Ollama as a local LLM. So it will go to Ollama and it will find the answer. That answer will be the most nearest answer from the document. This is about the top key results and how retrieval phase works in the RAG. Now we are going to write a code for these two topics. This is our code base and we have written the code till generating the embeddings and storing in vector database. Now the first thing here in the retrieval phase is first I need to ask a question. For asking a question I need to write a code to asking a input from the user. So this is all the code which we have written previous session. So first here now I'm going to change this file name ingestion to ingestion and query here, because here we are going to add the query part also in the same file. So here let me make a changes here, ingestion and query. The first thing is I need to ask a question from the user. So asking question is you go and ask the input from the user. So user is sending the query and we need to generate the query embedding here. So let me go and write a code for that. For generating the embedding I'm going to use the already existing method, that is generate embeddings. This is going to give me the embeddings for any of the given query. I'll call the same function, but before that first I need to ask a question from the user. So this is the question which I'm asking. So here I'm saying that input, enter your question about the document. Then I'll be calling the generate embeddings. For that generate embeddings I'm using this method which is already there. So query equals to generate embeddings, and in that I'm sending the question whatever I have received from the user. This is coming as a chunk here. Then I'm sending the model name. That model name is coming from the config. So I'm fetching from the config and sending here as a parameter. So once you generate the embedding, that you need to send it to vector database and do a vector search. Here you will go and find the similarity and then you will fetch the top 3 items from this and then you build a prompt. So first let me go and do a vector search here, and for that I'm using already existing client. Then I'll be using this client. Then here I'll be sending a query point. This is how I'll be doing a search and fetch the top 3 items from this. So this is the method, and this method will take a collection name, and after that I need to send the vector which I have generated for the question. Then I'll be sending a top 3 parameters. So this is the query, and here I'm mentioning as a limit as 3. As our document is little small, so I'm using a 3 as a limit here. Whatever the results which is coming, I am saving into a top matches variable. So once I get the top matches, let me go and print all the top matches whichever I'm getting, just to see that how it looks like. After that, whenever it is giving the top matches, it will have the payload also. From that payload I want to print the text. So let me go and run here whatever the code which we have created here. Let me go and run it so that you can see it how this query embedding looks like and how this matches looks like. So let me go and write Python ingestion and query here, and it is going to generate all the chunks. And if you go and see here, it has generated the question, the prompt also. Here I'm going to ask some question that how many leaves I have. These are the questions which I'm going to have it, and this question it has generated top 3 results. This says that it will have the text and it will have the score also, and each will have some information, and this is the top 3 result which I have got it. And this is the second chunk, this is the second result which has some more information, and this is the third result, this has some score. If you see, this has the highest score and it has most relevant answer which I've asked as about the leaf. This is how the top 3 results looks like whenever you ask any question. So let me go and remove this print and append all the hits which I am getting into one of the variable, that is text. Here I am creating one of the variable that is a text here. All the information which I am getting, that I am going to append into this text. Hit payload of a text. The entire text, that is nothing but the information which I will be saving in the text, so that I will be generating context out of it. So now once I got all the matching points and all the results from the entire document, so my next phase will be preparing the context from this top 3 retrieval. Why I need to prepare the context is I need to hit the LLM. So here I'll be adding a system context and then user query. Then on top of that I'll be sending this top 3 results which I have got it. Then I'll send it to LLM. LLM will give me an answer. So let me go and write the code for that. So here I need to build a new function to ask LLM. So let me go and write a new file here, ask LLM, and this will go and hit the Ollama model which we already have it here. let me write a import statement here, import request here. Then after that I'm going to write a new method. Before that, let me add the Ollama URL here. This is where we are going to hit, and instead of completions here I'm going to make it as a generate. Whenever we are going to ask Ollama, the request will go to this endpoint. Let me create a method here, ask Ollama. This will take question as a parameter that will be in a form of a string, and context also as a string here. And after that, instead of model name, I am sending a config here. First thing is I need to prepare a prompt. How do I prepare a prompt? Is this is the formatted string which I am adding, and here first I need to add some system prompt. System prompt is you are adding some instruction to the Ollama or the LLM, and you are saying that you are assistant and which will help me to answer the questions. That will be my system prompt. And after that I need to send a context. So here context is all the embeddings which we have generated for all top 3 results, and after that I am sending the question. After that I am adding some more information here that if you do not know the answer, please say that you don't know. That is a statement which I am going to add. Let me go and hit the LLM. Response equals to request.post, and here I am sending the Ollama URL which I have added above. And after that, in the JSON format, first I will be sending the model name, and after that I am sending all the prompt which we have prepared above. And here from the config I am going to pick the LLM underscore model. That will be my model name here, and then the prompt which we have already prepared above. And once I get response, I will be putting it into the one of the variable, and I am going to add a check that if this particular data has the response or not, because that is what we required. If the response keyword or the response key is not present in the data, then I'm going to throw an error. If not, I'm sending this response back to my main function. So let me summarize what we have written. First, we have created a prompt. That prompt will contain the context and the question, and then I'm hitting the Ollama, and here I'm sending a prompt and the model name. The model name is nothing but the model which you have added in the config, and that is coming here and generating the response, and I'm checking the response and return the response. Now let me go to a ingestion and the query file here and call this function there. Now I need to prepare the context. Context is nothing but all the top 3 results which I have got it. That will become the context, and then I'm doing a join of the context. Then after that I'm doing a step 6, that is nothing but asking the LLM. So here I'll call that function answer equals to ask underscore Ollama, and this will take question, context and config. Right? Context is nothing but the top 3 results. Question is nothing but which is coming from the user. Then I'm going to print the answer. So what we have written is user is asking a query, then we are generating embeddings for the query, then doing a vector search and picking up the top 3 results from this vector search. That vector search will be hitting this collection which we already have it. Top 3 results will be picked from this entire collection. That top 3 results we are using it to build a prompt. So once I am ready with the prompt, I am sending it to LLM, then it will generate me answer. Let me go and see this code. This is what code which we have written. So here we are sending a question, generating embeddings for it. Once we generate the embeddings for the given question, then we need to hit the database and find the top 3 results from database. For hitting the database, we are using a query underscore points method, and here I am sending the collection name. Collection name is from the database what we have. If I go collection, this will be my collection name, and after that I am sending the query embedding which is generated in the previous step. Then I am sending the limit. Then I'm going to print all the top 3 results here, and while printing I am taking the text from the payload and appending it to text so that I can build a context. So after that I'm building a context here. Then I'm calling one of the function ask Ollama here. That will take question and the top 3 results, that is nothing but the context, then the config. And after that I'm building a prompt here, then asking Ollama with the context which we have it, and once the response comes I'm returning the response. Let me go and run this particular code and see how it looks like. Opening the new terminal, Python, ingestion and query. So it has generated all 13 chunks. It has printed. Now I need to enter my question. It is asking me a prompt. Let me go and write particular question here. How many leaves I do have it? And it has generated the top 3 results. Okay, this looks like there is some issue while hitting the Ollama. So let me go and check here. While hitting the Ollama, we need to send one flag, that is a stream equals to false. That is nothing but if I want to fetch the response in a form of a JSON, I need to make the stream flag as a false so that I'll get the entire JSON response from the Ollama. Let me go and run this program again. Python ingestion and query.py. So it has generated all 13 chunks here. Let me maximize this console. Then I will ask a question here about the leaves, how many leaves I have. So you can see here it has generated the answer. As my question is very generic about the leaves, it has generated me answer which includes all the types of leaves and how many leaves I have. Now let me ask a specific question about the casual leaves. So let me run this code again, and here I am going to ask a specific question about the casual leaves. How many casual leaves I have it. So it is generating saying that exact answer according to the context you are entitled to 12 casual leaves annually. So this will be my answer, accurate answer from the document. Consider if we have a huge document, this will be very useful, and this is how the chatbot will be built for any of the given application. Let me go and run it again and ask a different question. So if you go and see the prompt, we have written one prompt saying that if you do not know the answer, say that you don't know. Let me ask some irrelevant questions which is not there in the document and see whether it will give me I don't know answer or not. As this document has only policy related information, let me go and ask question out of the document, that is who has joined the recent. So this is my question. Let's see what it says. Then it says that I don't know, the context does not provide information about the recent employees. So now let me go and ask another question from the document. Let me open the document here, and in this document let me go and ask something about principles. What are the different principles which I have it. Run this code again and write a question about tell me about company principle. 3 chunks here. It has given me some answer. This answer should be coming from the document, and if you go and search the document, it has picked the answers from this place. So this is about the retrieval phase of the RAG. That is what we call it as a chatbot, and entire code is committed to a Git repo. If you go to this repo, rag-demo is a repository name. I'll provide the link in the description. You can go and clone that repo and try out on your own with the different documents. And if you have any questions, do let me know. I'll be happy to answer. Thank you.